She just landed a job as a laboratory technician in a commercial lab. The problem is, the job is much more stressful than it needs to be. Jane spends her day frantically running between her lab and several centrifuge rooms to carefully stop, prepare, and restart the many centrifuges in time to do her cell preparation. All she really wants is a way to make her job and her day efficient. That's exactly what Laminar Wash by Curiox Biosystem provides. A hands-free automated solution that does automated, standardized, consistent, and reliable cell preparation, resulting in consistent and reproducible data. Thanks to its innovative technology, scientists can benefit from an improved cell viability, cell recovery rates, faster workflows, and better biosafety. With Laminar Wash, Jane doesn't have to run like she's training for a marathon, having the peace of mind to perform the best at her job while saving time. Request a demo now and see what Laminar Wash by Curiox can do for you today.
Good afternoon. Can you hear me? Good? Awesome. So, did any of you identify with any of that in there? Did it speak to you a little bit? Yeah, me too. That was my first job straight out of college. So if you or any of your colleagues identified with any of that, I would like to tell you a little bit more about what Laminar Wash can do for you and your lab. My name is Anne. I'm the automation lead here at Curiox. So, we all know that biotherapies have come a really, really long way. The fact that we've been here, that we can be here after 2 long years of not being anywhere at all, is proof that medicine moves at a really fast pace. We are here because of the advances in vaccine development, genome sequencing, cancer therapies, and all of that I'm sure we're all involved with in some way or another here. We've all been in touch with super advanced analytical tools, flow cytometry, mass cytometry, next-gen sequencing, et cetera, et cetera. But there is a key component. Oh, there we go. There's a key component of sample prep that still remains outdated even to this day. Did you know that the centrifuge was invented in the 19th century for dairy processing? Probably not what you want for your super high-tech biosamples. Another problem with the centrifuge is that it's really difficult to automate. You get a lot of inter and intra-user variability, and it's really harsh on precious cell samples. Here at Curiox, we believe that it's time for sample prep to enter the 21st century and join the rest of us here. With Laminar Wash, this presents an elegant solution to automation. There are various options to automate, as we'll talk a little bit about today. The results are reproducible and reliable, and the process is really gentle on your cells. In the time of such advancement in biotech that we all are a part of, Laminar Wash can really help us to unlock the power of these technologies. So, how does it work? This is a Laminar Wash plate. It is 96 hydrophilic wells surrounded by hydrophobic surfaces, which allows these droplets to form whenever liquid is added. Oops. There we go. Can you see the video? Sorry, technical difficulties out here. There we go. These allow these droplets to form. Every well holds about up to 80 microliters of volume, and there's an attachment that goes on that allows it to go up to about 150 microliters. So while the plate is on, when you add the cells and the antibodies, they will incubate with the cells. So you can see here in the animation, the pipette tip, you'll add your cells, your antibodies, any reagents that you want onto the plate. And you can use a multi-channel pipette as well. This process can be done either manually or with some kind of automatic pipetter. There we go. All right. So, once the cells are added with the antibody, there we go, they start to settle with gravity. Gravity works all the time, whether or not we're there to see it. So as the cells are settling, they're also incubating with the antibodies and the reagents that you put on them. In the meantime, unbound antibodies are still diffusing into the reagent. So everything that's debris, that's stuff that you don't want on your cells, will still remain in solution. Once that is done, the plate can be placed on the washer. So this can be done either manually or with a robotic arm or with any liquid handling platform. Once the plate is in the washer, you can customize your flow rate, the number of washes, the volume that you want to do. All these are application dependent and it's really flexible. When the plate goes into the washer, every well gets its dedicated 2 nozzles. One nozzle will dispense fresh buffer and one will aspirate old buffer. And this process happens really slowly and really gently, so it passes a laminar flow of buffer across the top of your cells. Through a process of serial dilution, you can do this as many times or as few times as you want. The cells are undisturbed and uncrushed by centrifugal forces, but all the stuff that you don't want, like unbound antibodies, debris, any dust that's in there will get washed away bit by bit. So you can see at the very end, all you get are cells at the very bottom of the well, bound to antibodies in clean reagent. And the washer will then give you your plate back at the very end. So let's look a little bit at the impact that centrifugation and or laminar wash can have on your cells. On the left, you see 2 microscopy images that were taken. On the left are cells processed by centrifugation. You can see the cells are really crushed and really squished. There's not that many of them left, and the cell signal is really weak. On the right, you'll see cells processed by laminar wash. The morphology is a lot more intact, the cells are happier and healthier, and the signal is much stronger. On the right, you'll also see some data on retention. So those of us who work with centrifuges a lot know that the lower your starting cell number is, the bigger a problem you have. Because lower starting numbers leads to a smaller pellet, which is harder to see and easier to lose. And so then you retain fewer cells, which really doesn't help your problem at all. But with laminar wash, we see consistently high cell retention, even at a low starting number. And there's no preferential loss of cell types while you're still getting all the debris and unbound stuff out of your cells. And it takes the guesswork out of where's my pellet. If you've ever worked with really, really few cells, you really can't see the pellet anymore after you centrifuge. So with laminar wash, you can take a look under the microscope and you can be confident that your cells are still there. All of us who are here at this conference who work with automation will know this will come as no surprise to you that automation really increases reproducibility. So we see that in this graph here. This was a case study done with some lice blood from humanized mice. And I don't know if you can see the color, but the blue bars, the really thin blue bars, are samples processed by laminar wash. And you can see the CVs are really, really low. It's much lower compared to the samples processed in the conventional method, which is how they've been doing it for decades and years. Here's another slide with some data. I'm not going to go into the details of it, but this slide really shows that laminar wash can remove a lot of the debris that's present in tumor samples. So if you work with tumor samples, you'll know that it comes with a lot of debris. It takes a lot of washing to clean the samples enough so that you can analyze it later. So if any of you also have automated gating strategies, this will help give you more confidence that your gating is correct because the populations are much better separated and there's less debris in the middle that clogs up your analysis. So at Curex, we offer multiple different types of solutions depending on your workflow, your needs, your budget, and everything. If you run only a few plates a day and you only run cell sample prep, the Auto 1000 is a really good option. Come and visit us at booth 1932, just over there. We're a friendly bunch, I promise. And the Auto 1000 is an HT2000 washer that we have integrated into a Hamilton Nimbus system. We've also developed a graphical user interface so you don't have to learn any code to be able to process this. There's also a buffer exchanger, so you can use up to 6 different buffers with your samples. If you run a lot of plates a day, but you only run cell sample prep, then you can connect the HT washer that we talked about before with a robot arm. Here are a couple of examples. So you can fit the washer into any existing or bespoke automation system. This is entirely customizable, and you can run up to 10 plates in about 20 minutes, which is really fast. We provide a platform-agnostic automation license key that you can write the driver for. So you can see here a couple of examples we've developed with PAA and with Thermo. Now, if you're running many types of assays, so not just cell sample prep, you're running ELISAs and other kinds of assays, then, and you're only running 1 to 4 plates a day, you can design your own workstation. So you can design your entirely new platform that you can customize to your needs around the laminar wash platform. And even if you run a lot of plates a day, that option will still work for you because you get to design it however you want it to be. This will be the perfect time to introduce our next speaker, Nelson Karamanzana, who is the automation lead for analytical development over at Kite Pharma. Nelson has designed and built his entirely own bespoke automation centered around laminar wash. So, here's Nelson.
Thank you, Curiox, for this invitation. I'd like to sort of admit to you guys that I'm one of the volunteer benefactors of the efficiencies that this technology has brought us. And so it improved by our process efficiency, particularly for things that are heading towards commercial testing and routine testing of our products by at least 75%. And I'll give you an overview on how we accomplished that. We started off with doing our own sort of automation design from scratch of integrating an agnostic liquid handler with a robotic arm plus an online reader, and the Curiox would be somewhere inside within that system. What this allowed us or enabled us was a scalable and an optimized process to execute our routine testing. And at the same token, it provides a walkaway experience for all of our analysts to then move their sort of recovered time to something that is more ideal or innovative and productive. And then at the same token, it provided, we will show you that there's some similarities as far as how the manual and automated process compared. And again, it's I'll give you a slight overview on what does, when you say, oh, but it improved my efficiency, it improved the process, what does that mean as far as a financial model? So here is an example of us comparing a manual plate and process with a Curiox plate. Pay attention to the blue stained die on the upper hand middle panel where you have what we call a gated for dead cells. You notice that there's much less samples coming out off of the automated system, and we think that's contributed by two things. First of all, dead cells tend to be buoyant, so they were more effectively washed off by the laminar flow system. And second, it could be because you've eliminated the systematic effects of compacting and decompression of cells during a centrifugation process. So therefore, you had a lot more viable cells to analyze within the process. Now here it's I've sort of wanted to show to you guys that when you are in a routine testing environment, yes, I know, as your sample number grows that you need to analyze, you could also grow your staff, but there's a comparison on why integrating an automated walk-away experience for routine testing is very important, because you see the comparison here. There's cost to a labor model implementation, and there's one for automation. One being is your space occupancy. A person requires parking, conference, lunch, and so on and so forth. While an automated integration, you can go as vertical as you can. And then you'll also see that for routine final testing, release of products, you're actually minimizing your exposure to variability to an invalid, which could be very costly for slowing down the release of a product. This is kind of an overview of a financial model that I was talking about when we're talking about net present value and stuff. So the bar graph in the back is kind of a demonstration of a year-over-year growth of your sample growth, particularly for the number of samples you're testing. And the solid blue line in the background is the amount of potential resources and FTEs required to run those tests. You see on the green line, there's a kind of an upward bump. Well, that's our ask. So there will be a large investment requirement, and people get scared by that right away. And this model tells you that there's an inflection point where immediately you will see a return on investment, the break-even point, and if you timed it carefully, when you see where I potentially asked for that money all the way up to where it flattened out, there's a very, very positive NPV from this demonstration. So you see that we have a good, strong financial model on why this technology is very beneficial for us. And it's one of those things that I sort of like think about, that I am grateful for Curiox for introducing us to this technology because it did improve our process. And I believe that for that, our routine testing on how we run it, it will be a game changer for the function of our process. And that's all I have. So if you guys have any questions, we welcome it.
Questions? Okay. Hold on, ma'am. Sorry, we need we've got a live stream.
How long did it take to integrate the system?
So that would be a phased-in kind of decision because depending on the test method that you're integrating, if it's going to be a regulated environment, particularly to the sample that I had where it goes towards routine testing of a commercial product, then you have to incorporate the development cost of remediations, the qualifications. So it's really up to what is required of that. And then at the same token, depending on what the original filing was, as far as the language is used, you may have to refile because let's say there's some filings that I've seen where they were very specific in describing, saying that, we used the P200 rain pipetter in this process to release it. And that becomes a constraint for us to introduce automation. While if now we're contributing to that language saying like, well, had you mentioned that it's a positive displacement, now you become technology agnostic. So these things that have to be worked out, it's a learning curve for all of us. And so this model really opened our eyes as far as identifying which ones to watch out for. And the future molecules and indications that we pursue, we wanted to make sure that those things are incorporated.
Okay, we have time for one more question.